On problems like this in ALEKS, we're trying to find how many gallons were used by each of two different cars. And this has similar problems are like this with distance, rate, time, or there's two things we need to figure out. So we really need to find a variable and then find equations and then solve essentially a basic system of equations. So if we read through this, a family has two cars. The one gets 25 miles per gallon, the other one gets 15 miles per gallon. They did a total of 1,450 miles, total consumption of 70 gallons. So really the first kind of on these is like, what don't I know, or what am I trying to figure out? So we've got this first car, second car, how many gallons they've used. So let's call this one how about F for the number of gallons used by the first car, and we could use S for the number of gallons used by the second car, or whatever you want to use. So all I do know is if I'm going to calculate how many, essentially how many miles I drive or whatever, if I take how many gallons by the first car times its mileage, which is 25, so if I made like 25F, that's going to be the mileage or the number of miles driven by the first car. And then if I add the second car, and so let's say here's second, and I do 15 miles for every gallon. So hypothetically, if the first car did 5 gallons, that F would be 5 times 25, and then if it's like 10, the second would be 15 times 10, and that would be the total. So if I take the amount of miles driven by the first car plus the amount of miles driven by the second car, we do know that those combined are 1,450. Problem is we've got an equation with two unknowns here, so we need to figure out another thing that relates these two. Well, it tells us that the total consumption is 70 gallons. So if I take F plus S, that equals 70. Okay, so really this is how we get two equations. We find a variable. We don't know how many gallons the first car, how many gallons the second car, assign a variable, and then try to use the scenario to figure out an equation that models what they're talking about. So hopefully that makes a little sense. As far as the first equation is 25 miles for every gallon used in the first car, 15 miles for every gallon used in the second car. Those combined, 1,450, and we know that F plus S is 70. So now we have two equations with two unknowns, and these aren't too bad. What I'm going to do here is try to figure out what F is. So to do that, I'm going to minus S from both sides of this equation. So the number of gallons used by the first car is going to be 70 minus the number used by the second car. So it's just everything left over, which makes sense. So now I can take this and substitute that in for F right here. So 25 parenthesis 70 minus S parenthesis plus 15S equals 1,450. So now we've got one equation with only one unknown, and the rest is some basic algebra. So if we distribute this 25 through, if we take 25 times 70, we get 1,750 minus 25S plus 15S equals 1,450. So if we combine like terms, write that over here, 1,750 minus 10S equals 1,450. And if we subtract 1,750 from both sides, so I can fit this in here, minus 1,750 minus 1,750. So I'll write that over here, negative 10S equals negative 300. And if we divide both sides by negative 10, S equals 30. So we know the second car is going to use 30 gallons, and that leaves us 40 gallons for the first car. So hope that video helps, and whenever you have a scenario like this, what they're trying to do is make you think about having two equations with two unknowns, and it's a rationale why you would need to solve this within a context. So it's a good problem, good little story problem there. Hope that helps.